Suppose that $10,000 is invested at 3.5% annual interest compounded quarterly. A, how much will be in the account in 5 years if no money is withdrawn? To answer this question, we'll use the formula for compound interest, which is A is equal to P times the quantity 1 plus R over N raised to the N times T power, where A is the amount in the account after T years with N compounding periods per year, and R is the interest rate as a decimal, where P is the principal amount invested. In this case, we were told that $10,000 was invested, and so P is equal to 10,000. The interest rate is 3.5%, so as a decimal, R is equal to 0.035. We are compounding quarterly, so N is equal to 4. And we're asked how much will be in the account in 5 years, so T is equal to 5. We'll substitute these values into the equation in order to find A. We have A is equal to 10,000 times 1 plus 0.035 divided by 4 raised to the 4 times 5 power. Simplifying inside the parentheses and evaluating the exponent, we get A is equal to 10,000 times 1.00875 raised to the 20th. Evaluating, we find that A is approximately equal to 11,903.40. So therefore, after 5 years, if no money is withdrawn, there will be approximately $11,903.40 in the account. B, how long to the nearest tenth of a year will it take for the initial principal to double? Once again, we'll need the compound interest formula. So we'll recall that that is A is equal to P times the quantity 1 plus R over N raised to the NT. The principal, P, is still 10,000. The rate is still 0.035, and we are still compounding quarterly, so N is equal to 4. In this case, we're looking for the time T that it will take for the initial principal to double. So we're looking to solve for T when A is equal to 2 times 10,000, or when A is equal to 20,000. So we'll substitute these values into the equation and then solve for T. We have 20,000 is equal to 10,000 times 1 plus 0.035 divided by 4 raised to the 4 times T power. Dividing both sides of the equation by 10,000, we get 2 is equal to 1.00875 raised to the 4t. Since t is in the exponent of our exponential expression, we are going to use the property that if x equals y, then log of x equals log of y. We'll use log of base 10, and we have log of 2 is equal to the log of 1.00875 raised to the 4t power. We can now use the power rule to rewrite the right side as a product. We have log of 2 is equal to 4t times the log of 1.00875. Now we can solve for t by dividing both sides of the equation by 4 times the log of 1.00875. So we have the log of 2 divided by 4 times the log of 1.00875 is equal to t. Evaluating, we find that t is approximately equal to 19.9. And thus, in order for the initial principal to double, it will take approximately 19.9 years.